Here I'm going to start off on a new lecture on stacks, and it's going to be the basic setup. Before we get started, I want to give you guys a quick definition on what a stack is. So as you can see here, I entered what are stacks in programming. All right, it says that a stack is an array or list structure of function calls and parameters used in modern computer programming and CPU architecture. All right, the process of adding data to a stack is referred to as push, while retrieving data from a stack is called pop. This occurs at the top of the stack. Okay, so that is your basic definition. Let me go ahead and show you some visuals here. So you can visualize stacks as some sort of container here, and as the definition described, there's two basic methods. You have either a push and pop, and the stack is similar to what we're going to talk about later, which is queue. A stack differs from a queue in that a stack goes by what's an acronym called LIFO, last in, first out. In other words, if you can visualize a container like this right here, all right, this outside here is a container, and what we're essentially doing is that we start off with nothing in the container, and if we want to add to this container, we use the push method. All right, that push method is going to push that data or node to the very bottom, and then if we want to add another one, well, that next data has to start off coming from the very top and is going to stack on top of the previous one that was added, and then the cycle continues. So a better way to even understand that further is well, here's some other definitions you can think. So it's like stack. Stack is like some cafeteria trays, or a stack of pennies, or a stack of your folded shirts, right? Typically, you're gonna go from the top, right? So you're first adding, you're adding to this layer and compiling to it, and then if you're going to retrieve from it, well, you typically go from the very top, right? Not from the middle, although you can, but it's very, it's normal that you just take it from the top. So that's kind of this demonstration here. But I like for me, I like to visualize it better, like something more restricted. Here you can see a tennis ball. I'm not a tennis player, but I know that the containers, if you can think of those tennis ball containers, when you buy them, they come in containers. And if you were to if you're wanting to remove a tennis ball, you can't go directly to the bottom or the middle, right? Because that container, like in this case here, you have container, you're restricted to just pull from the very top first. All right, so that's kind of like the whole thing where I said that a stack is last in, first out. So this, if you can imagine that these are all tennis balls here and inside a container, well, this very bottom ball here at the very bottom, that would have been the very first ball that was added to the container, and then the one on top of it would have been the second one added to it, right? But there's no way we can retrieve these first. We would have to start from the top, all right? And if the whatever is at the very top, well, that was the last one that was inserted, right? And so that's what a stack is. Another way is you can think of Pringles. If you ever Pringles are the same way, right? It's these chips are inside containers, and you can't go to the bottom or the middle. You have to go from you go from the top, right? Start pulling the chips one by one from the very top. So that is the stack. And some ways or stacks are used in different areas of websites. Like one example in which stacks are used is you can think of the browser, right? So for example, think of this container again, right? Think of, let's say it's empty to start off with, but we go through and search on Google some topic, all right? Well, that page that we search for first ends up, it's pushed into here, the container or the stack, and it's pushed to the very bottom. And then if you say on that page, you click on another link from that page, well, that new page is now added to the stack here. And then if you click on another link, well, it's added onto the stack again. All right, and then if you want to backtrace, right, because this is where the stack comes in use. because it does a lot of backtracking, is if you press that back button on your browser, say right here, right on Google has that back button. Well, what happens is that it goes through that stack and it pulls from the very top, right? Because that was the last thing we viewed. So I'll pull that out and then you'll go to that page. And then say you press the back button again. Well, then you'll go to the one that was below that. All right, and so on until you get to the very bottom, which was the very first thing from the get-go that you started searching for. All right, so as you can see, this is used in the internet. All right, and there's other uses too, but that's one way that you typically see it commonly done, especially if you use the internet. All right, so let's go ahead and start this stack. Let's go here. All right, so we're just gonna do the basic setup, and we're gonna create a node. Here, let's go here. So here's the pseudocode. We're gonna start off by setting up the node class. All right, this is very common. We've been using this a lot in other data structures. The node is what we're going to use to store data within. All right, so here we got our node class, and then we're going to set up the constructor for it. This is going to take a value as an argument. And we're going to have value equals the value. And then we're also going to have a next pointer. And by default, it's going to be null. All right, so there's our basic setup for the node. All right, so next is set up the stack class. Let's go ahead below that and do class stack constructor. Doesn't take any arguments. And here, the stack will start off with a blueprint of 3 properties. All right, those 3 properties it's going to start off with a top. All right, the top, and by default it's null, and this bottom is null. All right, now the way you can think of this is, remember, you can if you visually think of it, the stack is vertical, right? Kind of like that whole container thing with the tennis balls, right? So this is saying that at the very top right now, it starts off, there's nothing, and at the very bottom of the container, it's nothing. All right. Whereas when you were thinking of the link, a doubly linked list and some other data structures, we were kind of visualizing it from a horizontal perspective, right? So instead of top, like the top, it was kind of like the head, and then the bottom, it was sort of like the end, right, or the tail. So that's why in this case it's the same concept, but except we're giving it a name to kind of represent that visual representation of it, a stack being vertical from top to bottom. Okay, and then the final one is we're gonna have this dot size, and by default it's gonna be 0. And you can also call it length if you want, but in this case for this stack we're gonna call it size. All right, so this is your basic setup. As a matter of fact, I'm gonna instantiate a stack here, do new stack. All right, we're not gonna do nothing with it, but we will later on. And there's your basic ints. We initialized a stack to start off with. Okay, so let's go ahead and do that right here. I'm just gonna do stack, and if I at the bottom of the console, and as you can see here. And here's our current stack, all right, with its basic setup. So we got the bottom. Oh, no, my mistake. Let me go ahead and refresh this page here. Go back. All right, refresh this. And if I do ST for the stack, all right, so here's our basic setup. So you see bottom null, size 0, and top null. All right. That is it for now, and I'll see you in another lecture.